Okay, in this video, we're going to go through Chapter 4, Data with Two Variables. So that's going to be the goal, is to teach all through this chapter. Okay, so at the beginning of the chapter, they go through some vocab, so we're going to do that very quickly. Okay, univariate data means that you only have one variable. Okay, so uni means one, so this is having one variable. Bivariate data is when, you can probably guess, you have two variables. And when we speak of correlation in terms of mathematics, it is defined as the relationship between the variables. Okay, so these are important underlying premises as we start this section. So 4.1 talks about scatter plots. So if you plot your data, and this is bivariate data, okay, because you have X data and Y data. So if you plot your data and you get this kind of pattern, what you're seeing is as you increase the X's, the Y values also increase. That's a positive correlation. Okay, a positive upward slope indicates positive correlation. Likewise, if you are increasing your X's and your Y values are decreasing in this fashion, that is a negative correlation. If you end up having a scatter plot that looks something like this, then you can say that there's really no correlation between the X and Y variables. Okay? So I wrote here, because our textbook talks about this, remember that correlation is not the same as cause and effect. So on page 89 in the text, there is a plot of the killed Florida manatees versus the price of stocks. Now, there is a positive correlation when you look at the data. However, that's not a cause and effect. All right, so just understand that sometimes interpreting a positive correlation may be misleading. Okay, now a quantifiable estimate of the correlation between X and Y's can be attained using Pearsons correlation coefficient. Okay, so far we've spoken about a visual analysis when we looked at the scatter plots and we said, is it a positive or negative correlation? We can be a little bit more precise if we use the Pearsons correlation coefficient. So on page 90 of the text, it gives you a good introduction to this correlation, so I'm going to leave that to you to read. However, we are going to talk about the formula for it. So the Pearsons correlation coefficient is represented as this R. So this R can be attained by having S of XY and dividing that by the product, the square root of the product of SXX times SYY. And that value will be between -1 to +1 every single time. Okay, so that all looks kind of Greek with subscripts and values that I'm not sure what that even means. So let's talk about these three S's, okay, the three sisters. The SXX is really the numerator of the variance of the X values. Okay, the SXY, the SYY is similar to the numerator for variance between Y variables. This is the most important feature. The SXY gives you a relationship between the X and Y variables, and that's really what we're trying to capture. However, this SXY, as the textbook explains, is impacted by two things: by the variances of the X and Y, and also by the number of data points So in order to control that impact, we divide by an approximation of the variances of X and Y. Okay, so that's what's going on. That's some of the underlying premise. Okay, so this value R is therefore is also, other things about this value R. So first off, to get the R, dividing this way minimizes the impact of the variances of X and Y and of the number of data points. This value of R, that value itself, is not affected by changing units. So that's one thing. Okay, so it's not affected by changing units. So changing units, whether you change your units from feet to inches, that does not impact it. So that's good to know. And this R is also not affected by how you define your X and how you define Y. Whether you have X be the first term or X be the second term, it doesn't matter. So it's not impacted. So not impacted by, we'll say, order of X and Y, or just what you call your X and Y. You're still going to seem to see the same correlation. Okay, so I want to take one more step to go through some more things with Pearson correlation coefficient that's not on your sheet. So I'm going to go on the next page, and then we'll come back to the TI-84 application. So let's just move to the next page right now. Okay, so I'm just going to do a blank page. On page 94, and you can follow along with me, it gives you information on how to interpret your R value. So for example, if R is greater than -1, but less than -0.8, then you would say you have a strong negative correlation. Okay, so it's not quite, it's -1, and it could equal -1, so we'll say equal. Okay, so then what if you have a value that is between 0.8 and -0.5, okay, both of those negative. That would be a moderate negative correlation. Okay, so then continue with that thought. If your R is between -0.5 and +0.5, then you would say that there's a weak or really no correlation. Continuing in that vein, if your R value is between 0.5 and +0.8, you have a moderately positive correlation. And if your R is between 0.8 and 1, you can probably guess that you have a strong positive correlation. So you can see that being able to calculate an R value gives you an ability to really identify the correlation that you're seeing between your X and Y data, much more so than just a visual analysis of the graphical scatter plot. Okay, I want to go back to the TI-84 application, so let's do that on the next page. Okay, if you are asked to calculate your Pearson correlation coefficient by hand, how do you get these values? Using your calculator. But this is how you do it. So you go to Stat and you choose Edit, and you put your X values in L1 and your Y values in L2. You then click out of that and then return to Stat again, and now move to Calc, and you're going to go to two various stats. that's where you're going to find the components of the three S's. So what are those components? Okay, these are the components. So you could do this by hand. All right, those are the components. So if you look at your stats, you will see the sum of x squared. You will see the sum of x, which you can then square. You will see an n. You will see the sum of y squared. You will see the sum of y, which you can then square, divided by n. You will see the sum of xy, and you will see each of these components as well. So you can really get your own Pearson's correlation coefficient by just doing this math and relying upon your calculator to do some of the heavy lifting for you. Okay, let's go on to the next page. Okay, 4.3 talks about slopes and equations of fitted lines. Okay, so the idea about a slope is the slope is defined as the steepness of a line, and you can calculate that mathematically, and you're talking about the rise over the run. So here's your mathematical expression for calculating slope. So you would need 2 points. So 2 points on a line, given 2 points on a line, you can get back slope by using this equation. And as I said, slope indicates the steepness of the line. If it's a large positive number, it's very steep in a positive direction. If it's a large negative number, it's steep in a negative direction. Okay, here they talk about the calculation again, and you should be able to do these calculations. Your textbook can explain it to you if you have not seen this before. Okay, I want to go on to the different ways to write an equation of a line, and we'll do that in the next page so that we can see all of the components of that. Okay, so point slope form. Each of these forms has a gift, so I should back up and say that. They are each considered an equation of a line. In our current class, we tend to use slope-intercept form. So why don't I begin there so that we understand what we're doing? Okay, here is your generic y, that stays in the equation. Here is your generic x, that stays in your equation. M stands for mont, which means mountain in French. So M is your slope. B is your y-intercept. That's where your line crosses the y-axis. Okay, so that's the form that we usually use in our course, but I do want you to know all of the forms. Okay, another form that I really like is the point slope form. So y is generic, it stays. X is generic, it stays. x1, comma, y1 is a point on your line. M is your slope. Okay, notice, what's very important to take note of is this. This is negative. This is negative. However, if your y1 ends up being a negative number, then you would have y minus a minus number, which means that you might have a point slope equation of y plus something. Okay, let's go over that. What if I tell you that my xy is 2, negative 7, and my slope equals 3? How would I write that in point slope form? Well, I would say y minus a minus 7. I would never have a double sign, so that would end up being y plus 7 equals 3 times x minus 2. So notice that this sign has flipped by virtue of the y value that I was given. Okay, standard form is a form that tends to confuse people because you cannot read, generally, your slope or your x or y intercept directly from that form. So what you're going to do is you're going to set, this lets you get your x and y intercept. So to get your y-intercept, what you would do, so to get the y-intercept, you're going to set x equal to 0 and then solve for y. That gives you your y-intercept, which is your b in this form. To get your x-intercept, you're going to set y equal to 0 and solve for x. That gives you your root. Okay, so we're going to talk about this a little bit more on the next page, so I'll give you some examples to work with. Before we go on, though, I want to talk about two purposes for using our line. You can extrapolate, which means you can figure out what might be happening beyond your data. That's one thing you can do. But so extrapolate, extra is beyond. You can interpolate, which means that you could kind of figure out what's going on between the given data points. Okay, so that's two important reasons for analyzing lines. Okay, I'm going to do another blank page, and we're going to talk about standard form, point slope form, and slope intercept form a little bit more. Okay, look at this form. What information can I glean directly from this form? And what form is this? So you should be saying this is point slope form. So I know I have one point that I can readily identify. That point is -1, 3. Okay, do you see why the x is -1? It's because this would have been x minus a -1, which we never would have written that way. We would have written it as x plus 1. I also can read directly that my slope equals 2. So, can I graph this using that information? And the answer is yes. Okay, get your point. I'm going to go up by 1s for all of these grids. I'm not going to label it because I'm telling you what I'm going to do, and I don't want it to get too cumbersome. Okay, so this point that I've identified from my point slope form is -1, 3. So I go over -1 and up 1, 2, 3, and here is my point. My slope is 2. To get the next point, I start from this current point, and I go up 2 and over 1, because remember, slope is really rise over run, so I could write it like that. And using this form directly, I can write it out. Excuse me, I can sketch it out. Okay, can you take this form and change it into slope-intercept form? So let's see if we can. So I have y minus 3 equals 2 times x plus 1. Okay, I want y by itself. So y equals, if I add 3 to both sides, I'm going to get 2x plus 1 plus 3, right? Because if I added 3 here, that's gone. Add 3 here. Okay, now I'm going to have to distribute this 2 places. So y equals 2x plus 2 plus 3, which results in y equaling 2x plus 5. So what do I now know? I still know my slope, but now I know that my y-intercept is at the point 0, 5, which happens to be this point right here. So we've gone from point slope form, we used that form to graph our line, and then we went back to the form and changed it using algebra to slope intercept form. Okay, let's talk about standard form on the next page. Okay, what if you're given standard form, and this is your equation that you're left with? It's an equation of a line, and I want to use this equation to be able to graph my line. So what do I do? Okay, if I want to figure out the y-intercept, so to get the y-intercept, set x equal to 0 and solve. So that gives me 5 times 0 is 0, plus 2y equals 10, y equals 5. Okay, now get the x-intercept. You're going to set y equal to 0 and solve. So that's going to give me 5x plus 2 times 0, which is just 0, equals 10, and that means that x equals 2. So in terms of plotting this, this is what I now know. I know that my y is 5, so let's see if we can do this. 1, 2, 3, 4, 5, yep. So here's where my y value would be if I go up by ones, and my x was 2, that's where my x value would be, and then I would just connect those points, and here's a line. Okay, how do I turn this form of a line, 5x plus 2y equals 10, into the slope-intercept form? Well, get your 2y by itself, so subtract 5x, subtract 5x, rewrite your equation, 2y equals 10 minus 5x, divide every term by 2 to get y by itself, y equals 2 goes into 10, an even number of times, 5, minus 5 halves x. Okay, so that means that this equation has a y-intercept of 5, which we already knew because that's how we graphed it, but we didn't know the slope. So the slope is negative 5 halves. Does this make sense? So if I were to, usually it's rise over run, let's still start at the top and let's rise down. So go down 5, 1, 2, 3, 4, 5, and over 2. Does that give you your next point? Yes. So when I have a negative, I rise down. Whether I have a negative or a positive, I always run to the right. Okay? So that's working with standard form. So you need to be able to do this and be comfortable doing it. Okay, let's go on to the next page, which talks about the least squares line of best fit. Okay, so in life, you're generally not given an equation of a line. You usually have to estimate it yourself. So we're lucky in that we have technology that will help us do that. But there are two major ways to get your equation of a line. One is through least squares, and the other is the median line method. We generally, in algebra, use the least squares line, and the textbook is recommending that you can do the median line for middle schoolers because they can easily get the median of a data set. So both of these lines can be estimated using your graphing calculator also. So if you put your data into L1 and L2, you can get your least square line and you can get your median line. Okay, your least squared line in terms of running it, let's look where that is exactly. I'm going into stat, I'm going into calc. So do you see you have a Lin regression? Now it can be written two ways. It means the same thing, and the reason why the calculator did this is because textbooks sometimes write it two different ways. So they both give you the same results as long as you're careful in interpreting it. Okay, so we're going to call this, okay, this is 4 in your graphing calculator, and this is 8 in your graphing calculator. Okay, in 4, The A value they give you is your slope. That would be our M. The B is the y-intercept. With 8, the A value is your B, and the B value is your slope. So know which one you're running so that you know how to interpret the results. Okay, there is also a median line. Okay, that's number 3, and it says median. So if you run a median regression, then let's see what we would get. So that you'd be down on 3. So they would ask you to list your X values, tell them where your X values are, tell them where your Y values are, and you'll be good to go. And then you'll be able to get that equation. Okay, so let's go over the least squares line. So there's a good discussion in the text about why this is called the least squares, and there's all kinds of figures that go along with it. For our purposes, I would like to focus on the connection between the 3 S's and the slope. So look at this. This is very, very interesting. Slope is SXY over SXX. Remember the Pearsons correlation coefficient calculations? They appeared there also. So that would get us our slope. And then what about our B? Well, B equals Y bar, which is the average Y value of your data, times the M, the slope we just figured out, by doing SXY over SXX. And then we have X bar. X bar is your average of your X data. Okay, so with the TI-84, you can run a linear regression and not have to even use these points, but know that you could use them. Okay, so if you run it using either number 4 or number 8, you are bypassing this method and just going directly and using your calculator without going through the analysis of your your variables. Okay, so also, you need to turn on your diagnostics so that you can see what your correlation coefficient is, and the textbook tells you how to do that on page 105. So if you run a linear regression right now using the data on floor size as your L1 and number of sleepers as your L2, your data should give you the exact same equation that they got. So we're talking about getting Y equals AX plus B. So they have A equals 0.04036, and you would round that to some specified decimal place. B is 1.0737, I guess. And your R squared is 77.77, and your R is 0.88, which means you have a strong positive correlation between your X and your Y. Okay, so notice that if they're telling us that Y equals AX plus B, they must have run using number 4. So your A is your slope. So this is your slope, and your B is your y-intercept. Make sure you understand that. Okay, the median line we tend to not use in high school, but I do appreciate the fact that you could use this in middle school just as a way to analyze data without getting into a whole least squares regression discussion. So a second fitted line reviewed by our textbook is the median line. This line is included to demonstrate that there is more than one way to estimate a line, as I just said. Okay, I want you to read carefully pages 108 to 110 because it does cover it very well. Okay, this median line I told you is number 3 under stats. So for now, look for it now, run it with the current data you have in L1 and L2, and your data should match that of page 110. I do want to talk a little bit more about this because there is a problem in one of the problem sets that asks you to do this, so I want to make sure that you understand it. So I'm going to hit some of the high points from pages 107 to 110 about the median line on the next page. Okay, so the first thing you're going to do if you're going to do a median line, the first thing is you're going to organize your data and you're going to sort it so that your x's are ascending. So they go from low to high. Keep the pairing with your y so that they're paired with the right one. Okay, so then you're going to divide your data into 3 groups and 3 pretty equal groups. Left, which will be your low numbers, your low x values. Middle, which is your in-between. And high, which is your high x values. Okay, so once you do that, then you're going to find the median x and the median y for all of these sections. Now, be very careful finding the median y. Your x is sorted from low to high. Your y may not be sorted that same way. Before you find the median, you've got to sort your y so that within that grouping so that it goes from low to high, and then you pick the middle number. Okay, so then the next thing they tell us to do is you're going to find the line through the 2 outer values. So that means you're going to find it through the left median values and the right. So left, middle, this should have, sorry, so I'm going to erase this. I'm going to say this is right. Okay, so the left, and then let me erase this, and the right. Okay, so you get that line by taking those points and connecting them. That is your line then. You're not quite done because we've ignored the middle. So then you're going to figure out, find the line through the 2 outer, the left and the right, which we did in 4. Now we're going to move that line that we found vertically 1/3 of the distance of the y value of the middle point. So you're going to move that vertically. Okay, and that, so move it vertically. Move vertically 1/3 of middle y. All right, then the resultant line is called the median line. Okay, so on page 110, they go through the calculator version of it, which we kind of touched upon, but you want to make sure that you can do this median line. Okay, and that, I think, yep, that ends this chapter.